Today, we're going to be talking about load balancers and what it means to vertically and horizontally scale your application. When you have an application, you need to deploy the code you've written onto a host so that your users can interact with it. In the beginning, your user base is going to be very small. One host can serve all the traffic for all of your users. Scaling is not going to be a concern for you just yet. However, when your application starts to get more popular, you start to see that the CPU utilization on your host is exceeding 80%. This is where you should start being concerned about scaling issues. You run the risk of your application crashing and failing. One way to combat this is to vertically scale. Vertically scaling means getting a host that has better specs than the previous one. In our example, we got a host that has more CPU so that we can lower our CPU utilization. This allows us to increase the number of requests our server can handle at once and allows us to scale with the amount of users we're seeing. When it comes to vertically scaling, it doesn't always have to be just CPU. You can also vertically scale due to memory or network bandwidth constraints. However, one of the issues with vertically scaling is that there is physical and cost limitations. As you start to buy better and better hosts, it's going to get exponentially more expensive. Just think about how much it costs to buy a 1080 NVIDIA graphics card versus buying a 4080 NVIDIA graphics card. Also, at some point, you start to reach a physical limit on how fast a server could be. There's only so many transistors that you can put onto a CPU chip. So vertically scaling temporarily solved your scaling issues. You're able to take on more requests from more users and allows you to focus on building new features for your application. This is good news because the features that you've built out allows you to see exponentially more daily active users on your application. However, at some point you're going to hit the limits of vertical scaling. The next step is to horizontally scale. Horizontal scaling means having multiple servers and hosts serve all the traffic for your users instead of having one big beefy host. One host isn't being overloaded with all the requests from your users, but it's rather distributed across all the hosts in the group. One of the big advantages when it comes to horizontally scaling is that you're able to add or remove hosts from the group to match user traffic. For example, let's say we start off with one host and that we start to see CPU utilization go up to 80%. Once we see that the total CPU utilization and all the hosts in the group exceeds 80%, we can add another host to the group. Adding a new host spreads out the traffic load across the servers, so we effectively reduce our CPU utilization in half. Once we see that CPU utilization exceeds 80% between the two hosts in the group, we can spin up a third one. We can also dynamically remove hosts from the group as well. Once we start seeing that CPU utilization across all the hosts goes lower than 20%, we can remove one host from the group. This will disperse the traffic between the two hosts so that we increase the total CPU utilization. Dynamically removing hosts helps you optimize costs. There's no point of having 8 hosts up and running when you can serve traffic with just 3. Horizontal scaling is great because it allows you to be flexible by adding more hosts to meet traffic demand while also removing hosts to save costs. Now that you understand what horizontal scaling is, there's one more important step that you need to figure out. How do you even distribute traffic across the hosts in your group? You currently have no way to route traffic and requests to each of these hosts. So when users go onto your website, the website typically points to one IP address. But wait, shouldn't each of these hosts have their own unique IP address? Wouldn't this mean that your website can only send traffic to just one server? How are you able to distribute traffic across all of your hosts? This is where a load balancer comes in. A load balancer sits in between your users and a group of hosts running your application. The load balancer's job is to take a user request and pick one of the hosts running your application to forward the request to. But how does a load balancer pick which of these hosts to forward the request to? This is typically done by a load balancer algorithm, and there are many implementations of a load balancer algorithm. A common load balancing algorithm is a round robin algorithm. How it works is when you receive requests from your users, your load balancer will evenly distribute the request to each server. Request 1 going to host 1, request 2 going to host 2, and so on and so forth, and then repeat the process. This allows you to evenly distribute each request across all your servers. Another load balancing algorithm is called least connections. The load balancer will forward the request to the host that has at least the number of active connections. This ensures that we don't overload one specific host. For example, if we sent this request to host 1, it'll have 6 active connections. This would mean that we aren't evenly distributing the traffic and requests across all of our servers. When it comes to lowest latency load balancing, the load balancer will always pick the host that has the lowest amount of latency for the user. This ensures that the user will have the fastest response time. Another load balancing algorithm is called IP hashing. When the load balancer receives a request from the user, it'll get their IP address. It'll then calculate an IP hash, and with the hash value, it will always route the user to a specific host. With this approach, we don't look at the state of the host to determine which host we send the request to. We will look at the unique identifier, in this case, an IP hash. An example of how you can implement an IP hashing function is that given an IP address, you can take in the sum of all of the numbers in the IP address. You take that sum and then you mod it by the number of hosts that are in your group. That way, you can take the modded value and associate it with one of the hosts in your group. Another example is doing weighted round robin. When your load balancer receives a request, it can route a percentage of the request to a specific host. Host 1 will receive 60% of the request, host 2 will receive 30%, and host 1 will receive 10%. Now that you know what it means to vertically scale, horizontally scale, what a load balancer is, and load balancing algorithms, I want to tie in all these concepts with an analogy. These concepts can be applied to what it's like to run a coffee shop. When you first open up a coffee shop, you will only have a few customers. This means that one employee can serve as the cashier and a barista to take all the orders and make all the drinks. This is like having one server handle all the requests from your users. All the requests go directly onto the host. When you start to get more customers to your coffee shop, your one employee starts to get overworked. They can't handle the amount of orders they need to take and how many drink orders they need to concurrently make. Because of this, you decide to hire a professional barista. That way, this professional can handle a lot more concurrent orders and make a lot more drinks at once. This is similar to vertically scaling. In vertically scaling, you buy a host that has more CPU and memory to handle more concurrent requests. In a coffee shop, you hire a professional barista to take in more drink orders and make more drinks at once. However, having one employee, even if they're a professional, has their physical limitations. There's only so many orders that a barista can make at once, and hiring an even more professional barista is pretty much impossible. You've hit the ceiling of how many drinks one barista can make. This is similar to the physical and cost limitations of vertically scaling a host. In order to scale your business, you decide to hire an employee to be the cashier. The cashier can take all the drink orders, while the barista can focus on just making the drinks. Hiring a cashier to handle drink orders is like getting a load balancer for your application. The cashier helps take drink orders and pass it on to the barista, while a load balancer takes in a request and forwards it to the host. The cashier takes the burden of taking drink orders away from the barista. However, your barista still has a limitation of how many drink orders it can make at once. In order to scale, you hire more baristas to reduce the amount of drink orders each barista needs to make. This is similar to horizontally scaling. Once you start to see that your barista has reached the limit of how many drinks they can make, you hire on more baristas to help out. This is similar to when your group of hosts reach 80% CPU utilization. You need to add more hosts into your group to reduce the load of requests across all of your hosts. When a cashier takes in a drink order, how does that drink order get distributed across the baristas? We can take a load balancing approach to handle this problem. We can evenly distribute the drink orders just like a round robin algorithm. We can also take a least connections approach and forward the drink order to the barista that has the most availability. We can also take an IP hashing approach by forwarding drinks to a specific host based on their drink type. So barista 1 can handle all the lattes, barista 2 can handle the cold brews, and barista 3 can handle all the matcha drinks. You can even take a weighted round robin approach for this. If we have employees with different skill levels, we can forward 60% of the drink orders to the professional, 30% to the employee, and 10% to the trainee. Also, for your coffee shop, you expect to see most of your customers come in between 9 a.m. and 1 p.m. and you expect less customers between 1 p.m. and 5 p.m. Because of this, you schedule 10 baristas between 9 a.m. and 1 p.m. and 5 baristas between 1 p.m. and 5 p.m. Having more baristas in the morning helps you handle more drink orders when it's busy, while having less baristas in the afternoon helps you optimize costs when there's less customers. This is similar to horizontally scaling, where you can dynamically add more hosts depending on user traffic. You can also remove hosts in your group to optimize for costs. This allows you to be flexible to handle spikes in user traffic while also optimize for costs. Today we learned about vertically scaling, horizontally scaling, load balancing, and load balancing algorithms. That's all for today. Hope you learned something new. Take care, like, subscribe, and share. Thank y'all.